6th grade, Module 5, Lesson 11, problem set. Number 1, answer the following questions using this rectangular prism. What is the volume of the prism? So remember, volume is equal to length times width times height. So I'm going to do 9 inches times 1 1/3 inches times 4 2/3 inches. And I'm going to make everything into a fraction. So 9 over 1 times 1 1/3 would be 4/3 times 4 2/3 would be 4 times 3 is 12 plus 2, 14/3. So now we can multiply 9 times 4 times 14. 9 times 4 is 36, so let's do 36 times 14. 4 times 3 is 12, plus 2 is 14. Done with the 4. 1 times 6 is 6, 1 times 3 is 3. We get 504. And then 1 times 3 is 3, times 3 is 9. So 504 ninths. We just need to make that back into a mixed number. So I'm going to divide. 9 can't go into 5, but it can go into 54. Let's see, 9 times 5 is 45. That's as close as we can get. 9 goes into 54 6 times. So we get 56, and it is inches cubed as the volume. Linda fills the rectangular prism with cubes that have side lengths of 1/3. How many cubes does she need to fill the rectangular prism? So remember, if we had a rectangular prism and let me erase some of these parts. Okay. And we have cubes that have side lengths of 1/3. So that means side lengths of 1/3 for the cubes. And I'm just going to go ahead and break this rectangular prism into thirds so we can kind of visualize all of the cubes that would be in here. So we could fit that many cubes, 1/3 cubes with 1/3 side lengths into a prism. So that would be 1/3 times 1/3 times 1/3. You can either count them all and see that there are 27, because there's 9 in the front, 9 in the middle section, and 9 in the back section. Or 1/3 times 1/3 times 1/3 is 1/27th. So each cube takes up 1/27th of the entire thing, meaning that there would be 27 total cubes to fit inside of one large cube. So anyway, how many cubes does she need to fill the rectangular prism? Well, the volume is 56. So we know there are 56 larger cubes. So we could just do 56 times 27 and get however many we need. So 5 times 7 is 35, plus 4 is 39. 2 times 6 is 12, carry the 1. 2 times 5 is 10, plus 1 is 11. We get 1,512 1/3 inch side length cubes. So another way you could have done that was, we know that we could fit a third side lengths in there, so multiplying all of these by 3, and you could have done 27 times 1/3, 1 1/3 times 3, and 4 2/3 times 3, and then found the volume that way, or found how many cubes could fit in it that way. How is the number of cubes related to the volume? Well, the volume was 56 inches cubed times 27 cubes in each one of those, and we got 1,512 smaller cubes, which we could say that the number of cubes is 27 times greater than the volume. Why is the number of cubes needed different from the volume? Well, the number of cubes are needed is because they're much smaller. So as you can see, if we just did cubes that were, going back to this, if we just did cubes that were 1 by 1 by 1 by 1, then the volume would just be 56 inches cubed. But we have smaller cubes that are 1/3 by 1/3 by 1/3, and so you can see in one of the 56-inch cubes, we can fit 27 of those smaller ones in each one. So let's say the cubes are not each 1 inch, so the volume is different from the number of cubes. Number 2, calculate the volume of the following prisms. All right, we have volume equals length times width times height, 24 times 2 2/3 times 4 1/2. Centimeters times 4 1/2 centimeters times 2 2/3 centimeters. All right, I'll make them all into fractions. So 24 over 1 times 4 1/2 would be 9 halves times 2 2/3 would be 6, 7, 8 thirds. So let's go ahead and multiply. I'll do the bottom. Denominators, 1 times 2 times 3 is 6. So 24 times 9 times 8 is 72. So 24 times 72. 7 times 4 is 28. 7 times 2 is 14, plus 2 is 16. So we get 1,728 over 6. So let's divide and make that back into an improper fraction, or a whole number maybe. 6 can't go into 1, but it goes into 17. Let's see, 6 times 3 is 18, so it can only go in twice. 6 goes into 52. Let's see, 6 times 9 is 54, so 6 times 8 is 48. It can only go in 8 times. And another 8. So we get 288 centimeters cubed for A, and then let's do B. So B, we have 3 2/5 inches times 5 1/2 inches times 2 3/4 inches. So let's make them mixed numbers. Or they are mixed numbers, let's make them improper fractions. So 17/5 times 11 halves times, let's see, 8, 9, 10, 11 fourths. Okay, so let's see, 11 times 11, I think that's 121. Yep, so we have 121 times 17. $2,057 over 5 times 2 is 10 times 4 is 40. So let's divide that out. $40 can't go into 2 or 20. $40 could go into 205. Let's see, 40 times 4 would be 160. 40 times 5 would be 200, so it can go in 5 times. And 40 goes into 57 once. So we have a remainder of 17 over 40. So we get 51 and 17/40 inches cubed. All right, number 3. A rectangular prism with a volume of 12 cubic units is filled with cubes twice. Once with cubes with half unit side lengths and once with cubes with 1/3 unit side lengths. How many more of the cubes with 1/3 unit side lengths than cubes with 1/2 unit side lengths are needed to fill the prism? Okay, so it has 12 cubic units. And if we had 1/3 unit side lengths, that's like what we drew up here, you could fit 27 of those in there, right? So 27 in each cube, and there are 12. So 1/3 unit side lengths will be equal to 27 times 12. So let's do 27 times 12. Would be 324 cubes. If we did half unit side lengths, we would have 1/2 times 1/2 times 1/2. 2 times 2 is 4, times 2 is 8. We get 1/8, which means that we could fit 8 cubes inside. If you're having trouble picturing that, let me draw it. So we have half, cut them all in half. So you can see we have 1, 2, 3, 4 in the front, and then 4 in the back there. So there are 8 cubes there for half by half by half. So we can fit 8 cubes times there are 12 total in each of them. 8 times 12 is equal to 96. So 96 cubes for the half unit side lengths. And does it ask anymore? How many more cubes with 1/3 than with 1/2? So 324 minus 96. 14 minus 6 is 8. Gotta borrow again. 11 minus 9 is 2. So 228 more. More 1/3 unit length than 1/2 unit side lengths. B. Finally, the prism is filled with cubes whose side lengths are a 1/4 unit. How many 1/4 unit cubes would it take to fill the prism? Okay, so 1/4 unit now. So 1 times 1 times 1 is 1. 4 times 4 is 16. Times 4 is 64. So each one is going to take up 1/64th space, which means we can fit 64 cubes inside. And there are 12. So let's do 64 times 12. So that would be 768 cubes if the side lengths were 1/4 inch by 1/4 inch by 1/4 inch, or unit. Number 4, a toy company is packing its toys to be shipped. Each toy is placed inside a cube-shaped box with the side lengths of 3.5 inches. These smaller boxes are then packed into a larger box with dimensions of 14 inches by 7 inches by 3.5 inches. What's the greatest number of toy boxes that can be packed into the larger box for shipping? Okay, so we have 14 inches by 7 inches by 3.5 inches. And each cube-shaped box has a side length of 3.5. So we want to know how many 3.5s can fit inside of each of these. And then we can figure out how many can be packed. So I'm going to do 14 inches divided by 3.5. So I know 3.5 times 3.5. If I did 3.5 plus 3.5, I'd get 7 plus another 3.5 would be 10.5 plus another 3.5 would be 14. So I can fit 4 3.5s into 14. times how many 3.5s can I fit in 7? 2 times how many 3.5s fit in 3.5? 1. So 4 times 2 times 1 gives me 8. So I could fit 8 toy boxes into the larger box for shipping. Use the number of toy boxes that can be shipped in the large box to determine the volume of the shipping box. So if one small box was 3.5 times 3.5 times 3.5 inches, let's figure out what that is. So we get 6 7/2 times 7/2 times 7/2. 2 times 2 times 2 is 8. And 7 times 7 is 49 times 7. 9 times 7 is 63. 7 times 4 is 28. Plus 6 is 34. So 343 eighths. Let's figure out what that is. Eight goes into 34 4 times. And then 8 goes into 23. 8 times 3 is 24, so only twice. And 23 minus 16 is 7. So we get 42 and 7/8 inches cubed. But then what we need to do is take the 8 toy boxes, because there were 8 of those that could fit inside of there. So we're going to multiply this times 8 to get the volume of the total larger box, because that's just the large volume of one of the smaller boxes, but 8 of the smaller boxes can fit in the larger boxes. So if we multiply that by 8, which I'm not going to do because I just divided by 8, which I guess I didn't need to do. And when I did that, it was 343. So the answer would just be 343 inches cubed for the larger box. And number 5. A rectangular prism has a volume of 34 and 224 thousandths cubic meters. The height of the box is 3 1/10 meters, and the length is 2 4/10 meters. Write an equation that relates the volume to the length, width, and height. Let W represent the width in meters. So volume is equal to length times width times height. We know that the volume is 34 and 224 thousandths. So 34 and 224 thousandths would be equal to length, width, and height. We know that the length is 2 4/10 meters. We know that the width, or we don't know the width, but we know the height is 3 1/10. And then we don't know the width. So that would be our expression. Now we just need to solve it. I'm going to start by doing 2 4/10 times 3 1/10. I'm going to ignore the decimal points for now. Now there were 2 digits behind the decimal, so I'm going to move it over. So our new expression or equation looks like 334 and 224 thousandths is equal to 7 44 hundredths times whatever the width is. So I can figure this out by dividing by 7 44 hundredths, because remember I'm trying to get the width alone. So let's divide 34 and 224 thousandths divided by 7 44 hundredths. So I'm going to get rid of the decimal by moving it over 2 places, and I'll just move it up and forget about it. So now it's like 34,224 divided by 744. So how many times can 744 go into 3? 0. 34? 0. 342? 0. How many times could it go into 3,422? Well, 744 is pretty close to 1,000, and we're talking 3,000 So maybe 3 or 4 times. Let's try 4. Seven times 4 is 28, plus 1 is 29. So 2,976. Yeah, if I added another 744, I'd be way over 342. So it can go in 4 times. Let's subtract 2,976. 11 minus 7 is 4. 3 minus 9, lots of borrowing. 13 minus 9 is 4. So we get 446. Bring down the 4. So how many times could it go into 4,464? Let's see. Probably, let's try 6 times. Seven times 6 is 42, plus 2 is 44. Yep. Goes in exactly 6 times. Nothing to bring down, no remainder. So we get 4 6/10 is equal to the width, and it would be 4 6/10 meters.